Hi, everyone. Thanks for joining. And my name is Shivchander. I'm a principal research scientist at Red Hat. I'm joined here with Abhishek another principal research scientist at IBM. And today we're excited to introduce you to SDG Hub, our open source toolkit for data generation and language model customization. So here's what we'll discuss today. First, we'll start with why synthetic data is becoming the new scaling lever for large language models. Next, we'll introduce you to SDG Hub, our open source toolkit that makes building and running synthetic data generation pipelines simple and modular. And then we'll look at how to go from generic to custom, so bringing your data into your models. Finally, we'll wrap it up with some question and answers. And our goal is that by the end of this talk, you'll not only see why synthetic data matters, but also how you can immediately apply these tools for your use case. Sorry. Okay. Right. So why do we even need to go the synthetic route? Are we running out of real data? Over the last decade, we've sort of scaled our language models by feeding them more and more data. But now we're sort of hitting this critical point. These headlines capture it pretty well. The reality is that while our models are growing in sizes, the supply of high quality and diverse and publicly usable synthetic data is shrinking. We have scraped most of the web, we have digitized PDFs, books, and even pulled from social media. Beyond that, the marginal gains have been shrinking. So this creates a bottleneck. If you want to continue improving and pushing our large language models, especially for like enterprise or domain-specific use cases, we need a new approach. The second problem, about less than 1% of enterprise data is available in today's frontier models like ChatGPT or OpenAI. And that's a good thing. If it's anything more, that means your company is having a security issue. So most of the data that truly drives business values, like internal documents, transaction records, proprietary research, all of those doesn't exist in most of the frontier models. So these models are good for general purpose use case, but for enterprise, they're not really that great. So these are the two problems we are trying to approach with synthetic data. So back then, researchers thought, okay, to solve this problem, can we just use LLMs to train LLMs? Something like this. We use a language model as a teacher to generate data and train another language model, which will be the student. And this isn't just a theory anymore, or a research problem. It's already happening at every single stage of LLM pipeline. So you can now pre-train on purely synthetic data, instruction tune on synthetic data, and even evaluate your model using synthetic data. Today, we'll mostly be focusing on how to generate the instruction tuning data. So again, why we want to go the synthetic route first, and why now? Language models have become much more capable and stronger. Open source models have also got incredibly capable recently with GPT-OSS's release. They're now matching the frontier models like GPT-4, 5, and inference has also become cheaper and faster. And third, this is a very real use case. You can't really find real human-written data for all possible use cases. There will be some edge cases which real data cannot just handle. Language models excel in this particular use point. They can really interpolate and extrapolate between two use cases. So if you have a domain A and domain B, but you want data for a domain in between these two, language models can really interpolate between them and create data for you. So over the past few years, the research community has sort of exploded with new methods for generating synthetic data. There are a lot of algorithms and a lot of new papers. This is both exciting, but also like a bit overwhelming because each of these algorithms comes with their own code base and their own implementation and will will only work for their own setting and their own model. It's not really scalable, and there's not really a unified way to generate synthetic data using these algorithms. That brings us to the real pain point. So, how do I go about generating synthetic data? Which algorithm do I use? Most implementations are sort of ad hoc scripts from researchers. How do I adapt it to my domain, my company's documents, my internal use cases? Can I build my own pipeline without starting from scratch? These are exactly the questions we are trying to solve with this talk. With that, we'll introduce SDG Hub, which is our toolkit, which is going to be an answer to these questions. We sort of focused on having a modular design and have an intuitive workflow creation and also be scalable at the same time. Right, so now let's talk about SDG Hub. So what is it? So SDG Hub lets you create synthetic data generation pipelines, sort of like Legos. You can mix and match LLM-powered and traditional blocks and create your own pipelines. You can compose them into these YAML or Pythonically, and you can go from a single block into like a modified and extensible pipeline. And instead of stitching together these one-off scripts, you have a robust implementation and a standard one by which you can extend existing algorithms or create new algorithms. And why you should use SDG Hub? So we've sort of tried to replace these one-off ad hoc scripts. And we've also made it to be scalable. So any algorithm you implement in SDG Hub, just by implementation, is automatically scalable. So we have abstracted away the scalability from the algorithm designers. And it's easy to extend. You can take an existing algorithm, add a few new blocks, change the models, and you can generate your own synthetic data. So in short, we try to turn this chaos of multiple generation algorithms into one unified framework. So at the heart of SDG Hub is what we call blocks. This is an abstraction, and these are the building units for SDG Hub. First, there we go. Yeah, blocks are self-contained, and they are reusable units. Each one transforms the data set into something else. So data goes in, it does some processing on that particular data set, and it spits out the data set again. Second, they all share this consistent interface. And blocks are by nature composable. Any blocks can be connected with each other, and you can create your own generation pipeline. So on the right, you see this interface where that's how you can create a simple LLM chat block where you can specify your model, and you can give a prompt template, and this can run on your data set. Not just LLM, you can pretty much wrap any Pythonic function into a block abstraction, and hence it'll be modular, and you can use it in any generation pipeline. So the next abstraction, if blocks are like the building units of SDG Hub, flows are like the orchestration layer that connects them into complete data generation pipeline. First, flows let you chain these multiple blocks, LLMs, transformation, or any evaluation blocks, into a sophisticated pipeline. So instead of running one block at a time, you can just chain them together and run it as a whole. Second, these flows have a flexible definition. You can define them Pythonically, or you can define them in a YAML. That way, it's serializable. You can share it. So instead of sharing your code base with someone else, you can simply create your algorithm, export it in a YAML file, and share that particular YAML file to someone else, and they can run your data generation algorithm on their cluster. And third, these flows are built for optimized execution. You can dry run your data generation flow, test it, validate it. You can do full scale generation with async. You can do long generations, and then it has built-in parallelism as well. Right. So we've talked about the internal components, blocks and flows conceptually. So let me show you how very simple it is to start with SDG Hub. You don't have to build anything from scratch. So first, you can, with a single line, you can discover all the existing algorithms which are implemented, which we call flows. And then you can pick the ID of the algorithm, and then you can use that ID to simply grab the flow definition, and in just a couple of lines, you load the entire algorithm and the flow YAML into your pipeline. And then that's it. You hit generate, and now you're generating high quality synthetic data using that particular algorithm. So simple 3-step. You discover, load, configure, and then you generate. Right. Everything we have seen so far is blocks, the flows, the quick start. It comes out of the box, batteries included. But what if you want to generate something new, something tailored for your particular use case? With SDG Hub, the process is quite simple. First, check if you really need one. We have a big and a variety of blocks already pre-implemented. See if it solves your issues. If it doesn't, you can fill in the gap with custom blocks. Just create a simple Python function, wrap it with the block abstraction, and boom, it's already available to be used as a block in your pipeline. So on the right is a simple sort of boilerplate code which you can just add to wrap any Python function into a block. So in other words, you don't need to hack your way through the entire code base. We give sort of a clear path from how to go from discoverability to customizing production-ready software. With that, we have seen and sort of primed with the toolkit. I'll hand it over to Abhishek, who will cover how you can introduce your domain knowledge into the model using this SDG Hub toolkit.
Do you guys have any questions until this point? We can take like a minute if you guys have it, or we can move to the next. Okay, so thank you, Shiv, for going over SDG Hub. So what you saw is how do you use SDG Hub package to generate synthetic data. But then let's look into how you can use that to actually customize a model. So we'll dive into what customization means, how to use SDG Hub, and what to expect once you do this. Okay, so customizing LLMs for domain expert. So one second. Sorry, I think the slide was supposed to be before this. Okay, yeah. So customizing language models for domain expertise. So what that means is if I have a large language model, I would like it to be expert in a certain topic. How do I do that? There are open weight models. Every day new models are coming out. They're getting good at certain topics. Frontier models exist, like Claude or OpenAI. They are very good at a lot of topics, but the problem comes when you start using them for your downstream task. Say, for example, I'm a RHEL AI engineer, or say OpenShift engineer. I want to ask it questions about, say, my custom package, or I have a very specific problem I want it to solve. If it can't solve that, then really it's not serving its purpose of being an expert. So what I'm going to show you is how do you take a large language model, any open weight model, how do you customize it, and then once you have a customized model, you can do anything with it. You can treat it as a chatbot, you can put it in a large deep research framework, so connect it with something like Claude, make it even more powerful. It's basically, you can do whatever you like with it. Okay. So why does domain-specific knowledge matters? As Shiv mentioned, only 1% of enterprise knowledge is actually gone into these models. Or actually, not even 1%, it's less than that. That's because most of the knowledge is private. Most of these documents are never seen by any frontier models. When that happens, when you start using these models on your task, you're going to find them lacking or hallucinating on your topics. And training these, especially the frontier model, is difficult because you don't have access to these models. Now, the second problem, and the most common problem in enterprise, is when you start using these models, your data leaves your premise, which is not desirable for a lot of organizations. So that sort of limits your use case on what you can use. Solution is, can I just fine tune an open weight model? Say, for example, take GPT OSS. Can I just customize it for my use case? That would be very ideal if it can, given how good the model is. Okay, so I came up with two use cases to demonstrate how a customized model would look like. So for example, on the left, we have the hybrid architect advisor. So I'm not a cloud engineer, so I hope this is accurate. If it's not, just you'll get the point. So for example, I ask questions like, hey, I have RHEL running on my cluster. I would like to connect it to a third-party cloud provider. How do I do that? I would really like a model that can give me the precise steps on how to do it. I don't want the model to give me close to it. I want it to be precise. If it can't be precise, it's not really useful for my organization, right? And the second is, say, for example, I want to build an OpenShift expert model. Now, most of the OpenShift documentation is open source, so a frontier model will definitely get this. But say you made changes or you have very specific new packages coming up, I would like the model to know that. That is going to be difficult. And I'll show you how people deal with these problems, and there are some limitations and what can be done with that. But yeah, basically, if I ask a question like, hey, my pod crashed, what do I do? And you want the model to tell you, hey, here are the steps. Do this, do that, do that. And of course, like if your system is very custom, you want those steps to be as close as possible to it being workable. Okay, so with that, now that I've made a case for domain customizing a language model, let me tell you what knowledge tuning is. So knowledge tuning basically means, how do I take a large language model and make sure it can internalize your document or memorize your document so that when I ask a query, it can recall the knowledge. This problem is not as straightforward as you would think. There are certain problems. So traditionally, how people deal with this problem is, when you're training a model, you would inject those documents during pre-training. Now, this is a costly phase. For example, Granite models, when they're trained, they inject legal documents in it so that the model is very good at legal domain. But this is not something that can be done at every enterprise, because pre-training these models is very expensive, a time-consuming process, and there are some secrets involved that nobody really shows, except, I guess, Granite. So then the second most common way is I would inject the model post-training. So for example, I have a model, take Quen or GPT OSS. I can inject knowledge in the post-training phase. There are two most common ways to do it. The most common, which is retrieval augmented generation, which is basically saying, let me bring an external memory source and connect it to my model. So for example, I have a bunch of documents. I would put it in something called vector store. And when I ask a question, it just goes on that vector store, like it's like a data store, and finds the most relevant parts of your document and answers the question. This is the most used way of injecting external knowledge in enterprise today. There are some limitations to this approach. It depends on how complex your query is, the ability of the system to answer them. If you ask a question that requires a very precise information, it mostly can go and find that knowledge piece and give it to a language model. But if it needs to know, in general, what you're talking about, a bigger context to answer your query, it is mostly not going to be able to do that. That's where knowledge tuning comes in. So knowledge tuning basically says, all right, let me show the model my entire document, give it the context, make it an expert in this, and then once you have a domain expert, you can definitely club it with RAG or a deep research agent, however you prefer. Okay, so once you're okay with knowledge tuning the model, the most naive way is, let me just take my documents and just train the model on it. So this is basically called, let me just continue pre-training on raw documents. Now, this approach doesn't really work. In fact, this actually makes the model slightly worse on your domain. That is what we found through our experiments. And there is a lot of research showing that to make a model good at certain knowledge, you need to show the facts multiple times. with multiple augmentations. And this is actually a common known literature in machine learning. Generalization is only achieved when you do multiple augmentation of your data. And the same thing happens with language models too. So what you want to do is take your document, show it like different ways of representing the knowledge. And those ways also matters. So there's a lot of literature on people proposing different ways of augmenting it. I'll show you how we do it. Once you do this, once you successfully augment it, you will actually see when the model is trained, it is able to recall those facts. So when you ask the query in 10 different ways, it can actually precisely answer that. And it shows generalization, which is what we really care about. And of course, in the next few slides, I'll show that you can use SDG Hub. I'll point you to our notebook where you can achieve this. But let's go over the method first. So what we did is, through Instruct Lab and through the SDG Hub, we worked on our own method of knowledge tuning. So most of the literature focuses on how I can use very basic augmentation and improve my training methods. Here what we did is we focused on how we can use SDG or synthetic data to create different views of the document. Like for example, take a news article. I can take the article, directly train on it, or I can create different views. For example, a thematic summary. Like what is the main point of this argument, or what is the main point of this document? We can create sort of a list of key facts and make sure that the model remembers each key fact systematically to cover every knowledge. And the last piece, which is what has shown to work the best, is connecting these key facts. So what we did was we came up with 3 augmentations. The first 2 I described, and the third one says that find all the knowledge pieces in the document and make a connection between them. This is simply done by asking a teacher model, here's a document, can you first extract these key pieces and then make the connection among these key pieces? And everything's already implemented in SDG Hub. So the first part of our method creates this document augmentation. And the second part is to take these document augmentation and convert this into instruction tuning data. Why you ask instruction tuning data? Because we're going to be fine-tuning an instruct model. So it needs to have instruction data, just so that you don't break its ability to answer question and answers. So the 2 stages are document augmentation and then creating the instruction tuning data. And once you have that, our example notebook will show you how to take that data, convert it into a training format that pretty much any training library can consume. So I linked the QR code for our example notebook. This notebook will show you how to run different levels of augmentation, how to do data mixing. We haven't yet uploaded the results, but by next week we'll have more results on what size of data works, what to expect, how the model responses look like, and most importantly, when you use different teacher models, how does the data look? So I have mentioned this concept of teacher model, so let me quickly give you a primer on what I mean. When you do synthetic data generation, you need a very powerful model to give you the synthetic data. This is because powerful models are good at generating high accurate data and are able to judge it. So teacher model in this case would be a very large language model that you show your document to and create these different augmentations and synthetic QA pairs. And then a student model is the model you are interested in tuning, so fine tuning. You'll hear these words more throughout talk. The next talk is on how to train language models, and you might hear this stuff over there too. We will show you how different teacher models generate different types of data or different qualities or varying qualities of data, and how do you expect the performance to be. And we use a benchmark called quality, but we're also exploring some other benchmarks to increase the type of domain we tune and see how well it does. And again, these 3 augmentations in no way are general. They work on certain set of documents, but say, for example, you're dealing with a legal document, and you might feel like, okay, these augmentations are not really transforming the document I like. You can use the composable nature of SDG Hub, go and change prompts, add augmentations, or change existing ones, create new data pipelines, as easy as just copying it and just changing a prompt. And then you can just go over the notebook, go through it, see how it or how the data generation is done and the final mixing is done. Okay, so now we've seen, let's see how actually it looks like. So on the left is a Llama 3.1 8B model before fine-tuning, and on the right is the one after fine-tuning. I tested the quality benchmark, which is a collection of news articles and essays. And when I ask a simple question, right, the question is on a very specific article, and I ask it about what is Achilles' heel of the shopper. Shopping Avenger is a character in that essay. You'll see on the left the power of a foundation model, which is it does not know the answer, but it is trying to convincingly come up with a reasoning. I have highlighted, like, I need to consider this could be a plausible answer. But if it doesn't know the knowledge, its answer is never going to be correct. It might be able to guess something, but that is not what we want. On the right, you'll see a precise reasoning and coming to an answer, because it actually knows what you're asking about. And that is what we want, which is a precise answer, a precise reasoning, nothing else, not going off tangent and saying stuff. Okay. So we've seen how to prepare a language, customize a language model on your document. One thing you noticed is it's directly answering. It's not really doing what the newer models are doing, which is giving a big thinking trees followed by your answer. It is desirable to have that because reasoning will improve the quality of answer, especially if your query is complex. So recently, this week, we released a newer version of SDG Hub that now supports having GPT-OSS 120B as your teacher and as a student, so you can create a data out of it to tune a GPT-OSS. And then Mustafa will talk about his training library that actually enables you to train one. So I would really like to use something like GPT-OSS, Quen, or DeepSeek model. You can do that right now. Just simply switch the model. You're able to generate data where the instruction have question, reasoning, and answer pairs, so that when you fine-tune a model, it actually starts reasoning on your document. And then you can train it to think step by step on your domain. And let me show you an example. So this is the model I trained, GPT-OSS. GPT-OSS gives answer in multi-channel way, which means the first channel is analysis, the last channel is final answer, and then it can decide to give multiple channels if needed. And when I asked the exact same question as before, now it goes on a big analysis to answer it. Of course, this is a simpler question, so it doesn't need that much, but imagine if you had something like a SEC document, you started asking question like, can you compare last 10 years? I need a comprehensive result. Then this reasoning ability actually helps you get a good answer out of it. Okay. So I think with this, now that you have a GPT-OSS, let me just give you a technical feature overview of what we offer. So in SDG Hub, you can do knowledge tuning. It's easy to extend it. We have included a support for GPT-OSS as teacher model. We support OpenAI's Harmony format. So once you generate the data, you can use the data mixing to create the training data in a Harmony format, which means messages with user, assistant, and a thinking tag. And the final data is ready for training. And if you need to customize on your new domain, as I mentioned before, it's easy to extend the augmentations, add new flows, change the prompts, however you like it, you can actually do it. I think with that, I am at my last slide. We will keep updating, by the way, this SDG Hub with new methods. The hub in SDG Hub stands for a hub of methods. So we aim to add more and more methods, not just ours, but new research comes out. If a method is really good, we hope to add it. And of course, it's an open source project, so people can contribute their own methods, their own experiences, and so on and so forth. I guess that's it. We can take questions now, if anybody has. Yeah, go ahead.
Are there any examples of any cases where this technology will not be useful, any workflows where this, what we discussed today, would not be practical or useful?
Sorry, could you repeat?
Are there any situations where what we discussed today would not be practical or useful when developing models or in the industry?
So there are definitely cases where this won't be useful. That's what you're asking, right? Are there any use
Correct.
cases? Yeah, so this is not useful for every domain. Sometimes your problems are actually solved just by having a Claude agent or just simply reprompting any big model. This is useful mostly when you find that it actually lacks knowledge or necessary skills or it actually needs to improve on something, or you demand a very, very high accuracy because your system depends on it. That's the case. Those are the places where you might be. This might be more helpful. Do you want to?
Hello, hi. I work on the Red Hat Enterprise Linux system, and we are kind of doing a new project where we are helping customers to, recommend packages on their selection of packages. So, how would SDG help me to, better make better recommendations to the customers? Like, would I need to train the model in a particular way? I just want your views on this.
So that's a good question. I would ask you though, what is the problem you are running into right now with the system you have?
There's no problem as such. We are just using recommendation engines like we have on Netflix. Like if you select Python, we'll recommend you URL lib3 package or something related to Python. If you select HTTPD, we'll recommend you DNS or printing systems like such packages one after the another. So I'm trying to categorize these packages into multiple sections like applications, languages, browsers, then let's say printing, DNS, internet, something like that. So how would SDG come into picture if I want to bring it?
I think this could be like a classic knowledge use case. So if inference cost and throughput and latency is not a big concern, you can tune a very small language model on the documentations of your new features. And these, like, I think Walmart right now for their recommendation have moved on from using classical recommender models into like large language models. And basically how it works is it's trained on the product's queue. And even Amazon right now has Rufus AI, which is also a language model which is trained on product queues. So this could be like a classic knowledge use case where you can gather all the SKUs and documentations you have for your product offerings, generate synthetic Q&A data on top of it using SDG Hub, train based on how much latency throughput you can accommodate. You can train a small or a large language model.
Okay, yeah, sure, thank you.
Hey, hi. So how did you compare that it is better than the traditional rack system?
This is a good question. So traditional rack systems, so this scenario, right, is it better than, it depends on the type of task you're doing, right? So for example, for quality, what we noticed is the questions are usually very precise and require a single fact to answer. Oftentimes, there we are matching the rack system's performance. Mostly because, I mean, at that point, both of them can recall knowledge and answer it. So they pretty much operate neck to neck. But then there was another project. For that, we don't have a big eval because this was on a private set of code base. But we trained an agent on a code base to understand and answer questions about that. It's a private code base, so it has never seen before. What we noticed with RAG, a limited context is given, and somehow it is supposed to figure out what this is. Say, for example, in SDG Hub, if I give it a flow file, it's a YAML file, and without the context, it is open to interpretation what it's looking at. In those cases, the answer to those questions is pretty much hallucinated. It's guaranteed hallucinated. But when you use a tune model, it has the context that this flow file is probably a data generation flow from SDG Hub. So the answers are more precise. But we're hoping to have more numbers out to show you like a systematic comparison of like where it works and where it
Do you think that fine-tuning a model like this would be useful for like personal use? So, for example, if there were some tools that I use that tend to not get paid attention to by like ChatGPT or Claude when they're training their models, if I got the documentation from that and fine-tuned a model for my own machine, or would this be something that's mainly for like enterprise use rather than personal?
I think you can definitely use it on a personal tool. If you have this, you have the documents, you have the necessary file that explain how it is done, then you can definitely fine tune this on your personal data. And you can go a step further. There is a library called MCP agents. I don't know if you know this. It lets you convert any model into an MCP agent. So you can connect it to, say, for example, Claude Desktop. So next time you ask a question, Claude will invoke it, because Claude is not an expert, but it knows that there is an expert available. It will invoke it and answer a question for you.
Okay.
But it's a cool use case, yeah.
Yeah,
thank
we've
you.
also tried to like train a language model to sort of answer Q&A based on the SDG Hub repo. So we trained it on the repo, and we use it like a chatbot to answer questions to onboard users.
Okay, that's great. Thank you.